Really, there's only one rule to remember about ray tracing. You only need to draw two rays, two lines intersect to find a point, and you just need to find the point of the image. So the one rule that you have to remember is that something that comes in parallel will end up going through the focus. And then reverse that, something that goes through the focus will come out parallel. And so they're the minimum two lines that you need to draw. So we're going to draw the first one, which is something that comes in parallel is going to reflect, or in a lens, refract, such that it goes through the focus. And that rule, flip the other way around. If it goes through the focus, it will reflect or refract such that it comes out parallel. So it's kind of really just the one rule. Repeat it twice, and that finds us the point, which is the tip of the arrow, because the arrow is the object, and now this is the image of the object. The base is on the principal axis. There's no reflection or refraction, so that stays where it is, and that is as simple as it is to find where the image is, which is of course a real image because it's created by real light rays reaching that point. It's inverted and it's magnified. This is quite a useful little applet that helps you kind of get the whole business of ray diagrams. You can see they add a third line, which is the one that goes, through the center, is unrefracted or reflects out where the angle of incidence equals the angle of reflection. So it's kind of undeviated except bouncing back. You don't need that third line, but you can see this is the question in the first one. If I just change that to a mirror, you can see the rules that apply for lenses apply for mirrors. And so we found that one there. So the question is, what happens when the object is moved to a point between the mirror and the focus? Okay, so now at this point, the rules are still the same, right? The line that comes in parallel reflects out through the focal point of the mirror, and the line that appears to have come from the focal point is going to reflect out such that it goes parallel, which is this line here. That line, if you draw that one back, it's the line as though it came from the focal point, and it reflects back out parallel. So now we've got these two lines here, diverging lines arriving at your eye. And of course, your eye knows the rule about light, that it always travels in straight lines, except when it doesn't, except your brain's not good on the except. So it just assumes that those light rays have traveled in straight lines. And when it traces them back to the imaginary space on the other side of the mirror, then the point of the object is there. So they're not light rays. There could be a concrete wall on that side of the mirror. They're not real light rays. They're projections of a light ray that your imagination, your brain does. And they intersect to find the tip of that image, which you can now see it's upright. You can see that it is magnified, and you can see that it is a virtual image. So that would be the things that you would want to compare between the original image and this image. So just an examination technique. Whenever you're asked to compare or compare and contrast between two different things, set it out as a table, as I've done in the solutions. Now, the reason for that is twofold. First of all, a table is quick to draw up, and then you can just put dot points or words in and you've got your marks. It's a lot shorter and quicker and easier. But more importantly, when students kind of start writing out longhand a compare question, they'll often say something like object A is larger, and they don't actually say that object B is smaller. They imply it, but implying it is not saying it explicitly, and you may not get the mark for that. So good technique is always to use a table. If you find this kind of thing helpful, over here there's a whole database of these kind of questions searchable by Science Extension, Investigating Science and Physics, and by module. And if you're a teacher looking for really good quality trial exams and course exams, then they can be found here.